Hi everyone, I'm Chris and welcome to this machine learning course. In this lecture we consider the linear regression model to perform the regression task of machine learning. We start by explaining the regression task in general. Then the linear model is presented. A cost function quantifies the differences between model and data. The model training minimizes this cost function and the model is fitted to data. After the training process is considered, we look on the data preprocessing. Then we will learn how to select the best model for your data from several different models. At the end of this lecture, we consider regularization, which can enforce the desired behavior to a model. So let's start with the regression task of machine learning. A simple example of regression is to estimate real estate prices. A regression model is a mathematical function which takes characteristic features of the houses into account. For example, the house's length and width, or the year of construction or similar features. The model takes the values of these features as input and estimates the corresponding house price. The tuple of the values of all features for a single specific house is called a data sample. Typically, a model is a mathematical function with a specific structure which has trainable parameters. To indicate for the trainable structure of the model function, we place the trainable parameters as subscript to y tilde. So the dependencies of the independent variables are written in brackets at the function, and the trainable parameters are subscripted at the function. These trainable parameters are determined by fitting the model to data. This data, used to determine the parameters, is called training data. For our example, the training data is highlighted in green in the data table. So the model parameters are specified by training. The trained model can then be used to estimate the house price of a house with an unknown price. A more mathematical formulation of the regression problem is shown here. We want to estimate one or more target variables, such as a house price. The regression model wants to estimate such variables y1, y2, and so on, depending on features. So these target variables are also called dependent variables. Considering our real estate price estimation, the features are, for example, the length and width of a house. The features are also called independent variables to point out that they are not used as dependent target variable. These independent variables or features are represented by the variables x1, x2, and so on up to K. In the following, we will just use a single target variable y. The regression model which estimates this variable can be written as function y tilde. So y tilde is the model's approximation of the true value of y. The model function y tilde depends on the independent variables x1, x2, and so on up to K. So these independent variables are used as input for the model. Further, a model can have trainable parameters to fit the model to data. They are subscripted at the function denoted by beta 0, beta 1, and so on. The model is trained with data with known target values, the so-called training data. Here, in the sketch on the right side, the light blue dots. The training process fits the model function y tilde to the data by adjusting the trainable model parameters beta. Note that, especially for the trained model, we will omit the subscripted beta parameters to shorten the notation. The trained model y tilde can then be used for given values of x0 of the independent variables to estimate the target value, which gives y tilde 0. So this point is on the model's curve shown on the right side. So a model is a mathematical function with trainable parameters. The specific mathematical structure of the model defines a type of machine learning algorithm. Such algorithms can be, for example, linear regression or neural networks. And in this lecture, we start with a simple but very important type, the linear model. At first, we take a look on the simplest version of this model. We take only a single independent variable x into account. This linear model y tilde is given by beta 0 plus beta 1 times x. Here we have an explicitly written functional relation. To shorten the notation, we omit the parameters subscripted at the function as well as the independent variables in the brackets. This model represents a straight line. Beta 0 and beta 1 are parameters of this linear model. They are determined by fitting the model to training data. Geometrically, the parameter beta 0 is the y-intercept of the model's straight line. The parameter beta 1 controls the slope of the line. From this one-dimensional linear model, it is straightforward to multiple dimensions. The multiple linear regression model takes capital K independent variables x into account. The model is given by beta 0 plus beta 1 times x1 plus beta 2 times x2 plus and so on plus beta capital K times x capital K. With some notation, this can be expressed in short form. Thereby, we define x0, not used as variable before, as equal to 1. So we have the sum over k equals 0 to capital K of beta k times xk. On the right side, you can see a sketch of a two-dimensional linear model. So here capital K equals 2 and the model is beta 0 plus beta 1 times x1 plus beta 2 times x2. And this is geometrically a plane fitting the data. Section finished. If you liked this video, please click the like button and consider to subscribe this channel. If you have any comments or questions, please leave a comment down below. And thanks again for listening. See you in the next section.